You know what's really interesting is the universe. Several months ago, I think it was earlier this year, that two supernovas kind of got a little too close. They started dancing around and they ran into each other. Well, actually collided is the proper term. Now, what happens from that is when these two collided, they sent out a lot of gravity waves. Now, this is not the first time. This is like the fifth time. It's called a kilonova, where the gravity is so dense that just an ounce of neutron star is so dense that the size of a sugar cube would weigh as much as Mount Everest. So try picking that up off your floor. I'm just saying. But the thing is, though, when these two stars collided, they sent out gravity waves and all kinds of interesting things. From the article here, it says scientists just didn't hear a violent blast and seeing the ripples in space-time. They were able to use telescopes on satellites and on ground to see light and radiation that was being flung out of the explosion, which is known as a kilonova. And that information is going to be relied on for years to come. And scientists learn more about the beginnings of such stars and even our own universe, astronomers said. Every other gravitational wave detected has been traced back to black holes crashing together, which I said before, in remote regions of the universe more than 1 billion light years away. The new event, though still very distant, was much closer and completely different in nature. It was caused by colliding neutron stars. Neutron stars are the burnout remnants of giant stars so dense that a teaspoon of material on Earth would weigh a billion tons. So the two objects, about 12 miles in diameter, stretched and distorted space-time as they spiraled towards each other and finally collided. When these two collided, they actually expelled out a lot of different things. Radiation, which would probably dissipate like almost immediately because of the type of radiation it is. But they also created heavy elements like platinum and gold. And in fact, they created so much gold, it's almost the size of the Earth. Tony, your thoughts?
I think this is very interesting. You said that a tablespoon of sugar would weigh as much as 1 billion pounds. I mean,
it's not sugar. If you could put it into the size of a sugar cube, it would be that dense. It would weigh billions of pounds.
Oh, dang. Well, I just hope that Earth doesn't suffer any major consequences because I don't think the gravity can get any more dense here.
I think all the density that's going on is in Washington right now. Everybody's a little dense out there. So.
That is true, but yeah, I don't think it would be good for the environment because we're already dealing with climate change. I mean, the last thing we need is a more forceful gravity.
You didn't even notice that they happened because they went through you and they went through the planet. You didn't even notice. And the only way you could tell they actually happened is because of the LIGO detection centers that they have set up. Now, the LIGO is Laser Interferometer Gravitational Wave Observatory, or LIGO. I probably mispronounced the second word there. I got laser right. But basically, without a detector like that, you would never know. We've been bombarded by gravity waves probably your whole life, and you don't even realize it. It literally has no effect on you at all.
I did not know that.
Yeah. Now, this neutron star collision took place 130 million light years away. That's pretty close, actually. Not billions, but millions. In a relatively old galaxy called NGC 4993, when the gravitational waves began their journey across space, dinosaurs were roaming the Earth. So that's how long ago that these waves started their way here. So you ever go to the beach? You're like several feet from the shore, and you like say you put your hand in the water, you slap your hand in, or you drop a rock in. The waves spread out. They're concentrated right near the event, but as they get further and further away from the event, then they tend to get shallower and smaller. That's the same thing with the gravity waves. If we were like right next to this when this happened, if we were right near the event where that happened, oh yeah, we probably wouldn't survive. Most likely the planet would probably go kablooey. But we are so far away that those waves, they're ripples.
Okay, got you.
Okay, Matt, your thoughts?
Well, what's the worst that could happen? We can have a golden shower.
That's true.
If something did actually happen, I mean, if something did collide with Earth and there was gold in it, gold would be all over the place probably.
Yeah.
Oh, the Koch brothers would be the first ones there.
Yeah, absolutely. They probably would. Speaking of which, tonight there's a meteor shower going on right now.
I can't see nothing because it's cloudy out here.
Yeah, I don't know. I haven't been outside yet tonight. So, but we got a comment from the chat room from Deconverted Man. Thank you for your comment. He said gold would be devalued. Absolutely, it would be devalued. And I was talking with my daughter about that very thing and saying, if they were somehow able to bring the gold here, it would devalue gold completely. I mean, we only have a small amount of it. But what's really interesting is the fact is that the reason why we have gold and platinum and things like that is because of stars combining and exploding and recombining or whatever, stuff being shot across the universe. And that's why we have these heavy elements in our system and on our planet.
I wonder if like, when we get meteorite? I wonder if there's any of that stuff in there.
Most meteorites are made of iron.
Okay.
Most of them. Now, I don't know if there's any that have ever had metals like gold or platinum ever found on them. That I don't know off the top of my head. I'm not going to say that they did or not. I really don't know. But for the most part, they're mostly made of iron.
Well, I remember back in 2003, it was just after the Gulf War started. I was out in my backyard and I saw a meteorite. It lit the sky up and you could see it for thousands of miles. And like if you find a piece or a chunk or whatever, it's worth a lot of money.
Yeah, I think it's because of the nature of where it comes from. It's not so much the value of the metal itself. It's a matter of the fact is that, hey, this thing came from outer space and you were able to find it. You know, the Earth is probably littered with meteoroids all over the planet.
Oh,
you know, this time of the year, we go through this meteor shower. And like I was mentioning earlier, that because of that, mostly really small stuff like size of your fist or whatever, and it burns up in the atmosphere and it makes it, you know, it's really pretty to look at. But most of that stuff doesn't make it through. It's the bigger stuff that we have to worry about.
Right.